Hey everybody, welcome to Geometry, Section 10.3, the area of regular polygons. By the end of this lesson, you should be able to use the correct vocabulary in regular polygons, such as the radius and apothem, or some people call it the apothem or apothem. I call it the apothem. All right, it depends on which teacher you have. I think it's kind of funny because it sounds like someone saying, I was driving and then I hit apothem. Oh, dumb joke. Move on. All right, you also need to be able to find the area of regular polygons. You also need to be able to use special right triangles to find missing lengths. By special right triangles, I mean the 45-45 right triangle and also the 30-60-90 triangle. So let's start off with vocabulary. So first off, you should know this one, a regular polygon. A regular polygon is a polygon where all sides are congruent and all angles are congruent. So here I've got an example of a regular pentagon. So all 5 sides are the same, and then all 5 angles are the same. Here I have a regular hexagon. Again, all 6 sides are the same, all 6 angles are the same. So it's like the most perfect shape you can have of whatever polygon you have, all right? Next thing you need to know is the radius. And the radius is the distance from the center of the polygon out to the vertex of a polygon. So here I've got a radius for a pentagon, so it starts at the center and moves out to the vertex. So you can draw up to 5 radii in this one. However many sides there are, that's how many radii you can draw. Okay, we just have 1 here though. Next thing, the apothem. All right, so we made a stupid joke earlier, but here's what the apothem is. It's the distance from the center of the polygon to the center of the side. The apothem is always perpendicular to that side. So let's take a look. Here we start at the center, and the apothem goes out to that edge, and it goes right to the middle of that edge. And it really has no choice but to make a right angle with it. So if you go from the center to this center, it will always make a right angle. So just to be clear about this, the apothem goes from the center to the edge. The radius goes from the center to the vertex. So make sure you have those 2 things right in your mind. Last one, the central angle. The central angle is formed by drawing 2 consecutive radii in a polygon. What does that mean? Okay, if I draw 2 radii next to each other, it forms an angle at the very center of the polygon. So this is what a central angle is. It's not going to help us so much in this lesson, but it's going to help us in the next lesson, where we have to use trigonometry and fun stuff like this. An easy way to find this central angle is just take 360, because in any given shape there's, or any given center, there's 360 degrees, and just divide that by however many sides there are. So since this is a hexagon, you take 360, divide it by 6, and that's why that central angle is 60. If you had an octagon, you take 360 and you divide it by 8, and each central angle would be, what, 45? So moving on, how do we find the area of a regular polygon? Well, let's go back to that one picture that showed both a radius and an apothem. And I'm going to go ahead, I'm going to draw all the radii. So there we go, we got that. And if you take a look, when I draw each radius, I have just created 5 different triangles, okay? And each base of the triangle is one edge of the pentagon. I'm also going to draw every apothem. And I hope you can kind of see what's going on here, is because in this one triangle, the edge of the polygon is the base, and the apothem is the height. So I just went ahead and labeled each side the base, and I can label the apothem the height. So if I know that the area of a triangle is 1/2 base times height, what I can do is I can plug those, I can add up each base. And when you add up each base, that's actually the perimeter of the shape. And then the apothem is just the height. So that way we come up with this formula that the area equals 1/2 the apothem times the perimeter of the polygon. So if you didn't understand a single word that I just said, this is what you need to know. That formula. A equals 1/2 AP. That's the main thing I want you to get from this lesson, is that formula and how to use it. So let's take an example. Here I have a polygon. It straight up tells us that the apothem is 15. So I can go ahead and take that formula. The big A stands for the area. The little a stands for the apothem. So just to be clear. So straight up tells us that the apothem is 15, so I can go ahead and plug that in. The perimeter, it doesn't tell us, but we can figure it out. Each side is 18, and there's 5 sides. So for the perimeter, I just do 18 times 5, which is 90. Plug it in, and then all I have to do is crunch those numbers. So 1/2 times 15 times 90 is 675. Not too bad. Here's one. Okay, it's a hexagon. We know each side is 9 inches. Okay, this one might be a little bit more difficult. So let's analyze this, okay? We were talking about a radius and an apothem, but we don't have either one of those in this case. All we have is just how long one edge is. So first thing I can do is I can go ahead and I can figure out the perimeter. So since each edge is 9, there's 6 sides, so 9 times 6, I know the perimeter is 54. And if I want to, I can go ahead and just plug that in. So I still need the apothem. So let me go ahead and draw the apothem. And while I'm at it, I can go ahead and draw a radius too. And here's something that you need to know. And this happens in a hexagon and a triangle. Those are the only 2 shapes it happens in. But when you draw a radius and a apothem in a hexagon, it creates a 30, 60, 90 triangle. Okay? That's going to be important to know. So this does not happen in a pentagon. It happens only in a hexagon and an equilateral triangle. So here's my logic. If one entire side is 9 and the apothem goes to the very center of that side, wouldn't the distance from the right angle to the 60 degrees, wouldn't that just be half of 9? So now I've got this part being 4.5. So the short leg of this triangle is 4.5, which makes the long leg 4.5 times the square root of 3. Okay, is that starting to come back to you? So now I know the apothem. So I can take that and I can plug it in. So my formula is 1/2 4.5 times the square root of 3 times 54. Crunch all the numbers, so I'll do 1/2 times 4.5 times 54, and I'll get 121.5. And I just left the square root of 3 as the square root of 3. Okay, I would be fine if you left that as your answer. 121.5 times the square root of 3. If you wanted to crunch it a little bit more, if you wanted to find the decimal approximation, it'd be about 210.44 square inches. However, I'm fine if you leave the square root of 3 in there. Let's try another one. Okay, here we have a square, and we see that the radius is 7. Well, the radius is not the apothem. The radius does not help us get the perimeter. So how are we going to do this? We don't have any information that we need to plug in. Well, much like the last one, we had to use a special right triangle. On this one, we're also going to use a special right triangle. Let me go ahead and draw the apothem. And when I draw that apothem, I've just created a 45-45 right triangle. And this only happens in a square. So don't try doing this on an octagon or a decagon or anything like that. Only in a square do we get the 45-45 right triangle. So in that 45-45 right triangle, that 7 is the hypotenuse. It doesn't have square root of 2 on it. So you may recall the way we get the 2 legs is we cut that hypotenuse in half and then slap that square root of 2 right on there. So I know that the apothem and that other part of the triangle is 3.5 times the square root of 2. Okay? So now I know the apothem. I can go ahead and just plug that in the formula. Let's work on the perimeter. Well, if this part of the triangle is 3.5 times the square root of 2, that means the other part of that side is 3.5 times the square root of 2, which makes that entire side 7 square root of 2. Now, if each side is 7 times the square root of 2, to find the perimeter, we just multiply that by 4. And so I get my perimeter is 28 times the square root of 2. So now I can go ahead, plug that in, and I've got all the information that I need. However, it looks a little bit complicated. I've got some numbers that are underneath the square root, some numbers that aren't. So the way we multiply all this is all the numbers that are not underneath the square root, I can multiply those. So I can multiply 1/2 times 3.5 times 28. And then the numbers that are underneath the square root, I can multiply those together. So I've got square root of 2 in one place, the square root of 2 in another place. I can multiply that together. So basically everything that's under or outside the square root of 2, multiply. Everything that's underneath the square root, multiply. So when I do that, 1/2 times 3.5 times 28 is 49. Square root of 2 times the square root of 2 is the square root of 4, which is 2. So then I just multiply and I get my area is 98 square yards. Last example here. Oh, it kind of looks like my big head's in the way. Let's go ahead and move this. All right, so here we have an equilateral triangle, and they've gone ahead and they've drawn the apothem, which it's kind of hard to see, but the apothem is 8 centimeters, so let's blow that up a little bit easier to see. And like I said before in the hexagon, if you draw a apothem and a radius in either a hexagon or an equilateral triangle, you do create, well, first off, yeah, if we know the apothem, we can go ahead and plug that right into the equation. But when we draw the apothem and the radius, we create a 30, 60, 90 triangle. Okay? It only happens in a hexagon and an equilateral triangle. So if this 8 is the short leg, then I would know that the radius is 16, because that's the hypotenuse. Well, that 16 doesn't help me any, but still good to know. And if this short leg is 8 centimeters, then that means the long leg is 8 times the square root of 3 centimeters. So if from P to B is 8 square root of 3, then P to A is also 8 square root of 3, which makes that entire side 16 square root of 3. So to find the perimeter, let's just, since there's 3 sides, 3 times the 16 square root of 3, and I get 48 square root of 3. So let's plug it in, and I get 1/2 times 8 times 48 square root of 3. Multiply that all together, and I get 192 square root of 3 square centimeters. Well, I hope this wasn't too bad for you. I think the formula itself is relatively easy. I think the trick is going to be using special right triangles to find those missing lengths that we need. But we went through every scenario, one where they give you the side, one where they give you the radius, one where they give you the apothem, and we mastered every single one. So hopefully this isn't too bad for you. If you guys have any questions, please feel free to reach out to me, either via email or ask me questions in class. And I hope you guys do all right on this. Have a good one. I'll see you soon.